Welcome, engineering and security leaders. Today we are tackling a massive architectural collision, the intersection of post-quantum cryptography migration and frontier AI. We will explore how Anthropic's Claude Mythos is acting as a system-level disruptor, taking a 15-year transition and violently compressing it into just a few years. Let's get started. Let's lay the groundwork by defining the PQC mandate. What is PQC migration? It is the global transition to quantum-resistant algorithms formalized by NIST standards FPS 203, 204, and 205. The basics dictate that this isn't just updating a library, it is a massive system of systems redesigned touching everything from firmware to network gateways. Why is this so daunting? Because historically, enterprise migrations of this scale take 12 to 15 years. How do we traditionally handle this? Through a slow, sequential waterfall approach consisting of discovery, planning, and execution. But as we take a deep dive today, we will see that the arrival of Anthropic's Claude Mythos has completely disrupted this model. Mythos possesses automated reasoning and exploit discovery capabilities that shift the entire timeline, turning a decade-long project into an urgent, compressed race. Take a look at this flowchart contrasting the two paradigms. The quantum threat drives the NIST mandate. On the left, the traditional migration routes through sequential phases, resulting in an agonizing 12 to 15+ year duration. On the right, the Mythos disruption intercepts this process. By injecting parallel automated phases, the timeline is violently compressed down to a 2 to 4 year window. This visual perfectly illustrates why sticking to the traditional track is no longer mathematically or operationally viable. How exactly does Mythos compress a 15-year migration by 6 or more years? What we are looking at is the compressed track, projecting a 2 to 4 year migration window for highly exposed systems. The basics of this compression are rooted in adversary economics. Mythos has dropped the cost of automated vulnerability discovery by a full order of magnitude, with documented campaigns costing less than $20,000. Why does this matter for you? Because adversaries will use open-weight successors of these models to attack your legacy systems before your 10-year roadmap is finished. How do we survive? Defenders must adopt Mythos-class AI to parallelize the migration. The deep dive realization here is that Mythos eliminates the human labor bottlenecks in analyzing software, allowing simultaneous discovery and execution. However, remember that it cannot speed up your hardware procurement or government FPS validation cycles. Let's break down the new AI-augmented lifecycle, starting with Phase 1, Automated Discovery. What is this? It is the exhaustive mapping of every cryptographic touchpoint in your architecture. The basics are grim. Traditionally, this takes large enterprises 6 to 18 months of brutal manual code and binary review. Why do we do it? To generate a cryptographic bill of materials, or CBM, which is foundational for compliance and security. How does Mythos change this? By unleashing its massive code reading throughput, Mythos automates protocol decomposition and extracts firmware dependencies, compressing months of human labor into literally days of compute. Diving deeper, Mythos doesn't just hand you a flat spreadsheet. It delivers a ranked, intelligent touchpoint register, weighting each vulnerability by exploitability and network fanout, providing immediate, actionable triage data. This flow diagram illustrates the Mythos mapping engine. On the left, massive inputs including enterprise codebases, compiled binaries, and network traffic feed directly into the Mythos analysis plane. Inside this node, the AI performs its deep semantic reasoning. Out the other side, in days instead of months, we get an exploitability-ranked CBOM and a protocol dependency graph. These structured, highly intelligent outputs flow immediately into Phase 2, demonstrating how the traditional sequential handoff is entirely eliminated. Moving to Phase 2, Planning and Protocol Redesign. What happens here? You must map the NIST algorithms, like MLKM and MLDSA, to your specific systems. The basics reveal a huge physics problem. PQC keys are massive. An MLKM 768 public key is 1,184 bytes, and an SLHDSA signature is over 16,000 bytes. Why is this terrifying? Because injecting these into standard Ethernet or TLS handshakes aggressively exceeds the maximum transmission unit, or MTU, causing catastrophic fragmentation and dropped connections. How does Mythos solve this? It operates as a predictive simulation engine. It models your MTU boundaries and radio frequency tolerances instantly. The deep dive value is that Mythos short-circuits the traditional, expensive build test measure loop. It proves exactly which configurations will cause black hole routing failures before your engineers ever write the code, saving months of trial and error. Let's walk through the sequence diagram to see Mythos's simulation in action. Mythos injects a massive 3,309 byte ml DSA 65 signature into a TLS handshake. It attempts transmission over a standard 1,500 byte MTU link. The network instantly returns a fatal fragmentation drop. Mythos catches this, analyzes the failure, and recalculates entirely in simulation. It then proposes a custom hybrid mode split, breaking the payload into manageable chunks. The protocol transmits the chunked payload, and the network returns a success. This entire architectural redesign happens autonomously in seconds. Now we hit Phase 3, execution. What is this? This is the physical rewriting of your code, firmware, and public key infrastructure. The basics of traditional execution dictate that your speed is strictly limited by your headcount. You can only rewrite as fast as your developers can type. But why is this phase so different now? Mythos introduces what researchers call simultaneity pressure. How Mythos doesn't work sequentially. It can autonomously draft architectural pull requests for hundreds of different subsystems at the exact same time, swapping out legacy elliptic curve code for new PQC libraries. The deep dive paradigm shift is this: code generation is officially no longer your bottleneck. Your new bottleneck is human review capacity. Because AI models can hallucinate, absolutely no AI-generated code can be permitted to enter a production cryptographic path without rigorous review by a qualified human security engineer. This flowchart visualizes simultaneity pressure. At the top, the Mythos orchestrator spawns multiple parallel agents. One updates Cloud PKI, another rewrites TLS libraries, and a third refactors IoT firmware all simultaneously. However, notice the critical convergence point, the human security review node. All automated work must funnel through your human experts. If approved, it goes to production. If rejected, it loops back to Mythos for correction. You must scale your review team to handle this massive influx of AI-generated architecture. Phases 4 and 5 cover validation and continuous assurance. What are these? They're the processes of proving your new PQC systems are interoperable and secure. The basics are that traditional, annual penetration testing is now obsolete. Mythos-era threats require continuous, machine-speed red teaming. Why? Because adversaries are using these exact same models to continuously probe your transitional hybrid architectures, looking for ways to force a cryptographic downgrade. How do we defend? You must turn Mythos inward, using it as an automated red team engine to relentlessly generate attack paths against your own networks. The deep dive takeaway is a fundamental shift in your cost model. While AI makes writing software drastically cheaper, your enterprise must significantly increase its budget for continuous validation and assurance. The testing phase is now your most critical and resource-intensive survival mechanism. This state diagram shows the infinite loop of continuous assurance. Once PQC is deployed, the system enters a relentless cycle. The Mythos red team automatically generates attacks. If it detects a vulnerability, like a hybrid downgrade flaw, it shifts to drafting an automated patch. This draft requires human approval, which then hardens the deployed state. The cycle never stops. This is the only way to maintain security in an environment where AI adversaries are constantly evolving their attack generation. Let's lock this in with a highly critical real-time use case, upgrading tactical RF networks and cross-domain gateways. What is the scenario? A critical infrastructure provider needs to put PQC on a legacy radio system. The problem is severe hardware limits. The radio only has 512 kilobytes of flash storage and a tiny 256-byte MTU. Furthermore, the network is protected by a cross-domain gateway that enforces strict, byte-level parsing. The exploit risk here is massive. Adversaries can use AI to craft maliciously fragmented PQC handshakes designed specifically to confuse the gateway's reassembly logic and bypass security. The solution: you deploy Mythos. Mythos ingests the radio's RAM limits and the gateway's exact rule set simultaneously. It autonomously engineers a custom hybrid protocol that safely splits the massive PQC payload across multiple RF frames without triggering a gateway fault. This deep dive proves the model's ultimate value: cross-domain reasoning. It solves complex physics and network logic simultaneously, seeing solutions that siloed human teams consistently miss. This sequence maps the tactical battlefield at the gateway. The AI attacker sends a maliciously fragmented PQC payload. The gateway's legacy parsing logic is confused, accidentally granting a bypass and causing a breach. Enter the Mythos defender. It analyzes the byte-level vulnerability instantly, generates an MTU-safe protocol, and deploys a hardened parsing rule set to the gateway. When the adversary repeats the attack, the gateway successfully blocks it. This demonstrates the critical need for machine-speed defense against machine-speed attacks. In our final slide, we must confront the absolute limits of this technology and the required governance. What can AI do? It cannot compress physics or bureaucracy. Your institutional change management boards, FPS 140 to 3 module validations, and physical hardware replacement cycles are bound by human clocks. The basics are clear. If you attempt to use AI to bypass regulatory authority to operate renewals, you will face massive compliance failures. Why does governance matter so much? Because this technology is inherently dual use. The exact same Mythos model you used to build your PQC architecture can be prompted by a rogue insider to discover downgrade attacks against it. How do you survive? You must implement ruthless access controls, log every single query, and mandate strict human-in-the-loop reviews. In conclusion, PQC migration is no longer a standard IT upgrade. It is a high-stakes, AI-accelerated race for survival. You must restructure your programs today. To master these advanced architectures and future-proof your enterprise, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our closing mind map outlines the pillars of PQC and AI governance. At the top left, we acknowledge the uncompressible limits, FPS validation, hardware life cycles, and compliance. To manage the AI, we need strict access controls, including query logging and sandboxing. This must be paired with human oversight, mandating code reviews and formal risk acceptance. Finally, strategic survival demands that we embrace parallel execution and continuous red teaming. Internalize these pillars, and you will successfully navigate the post-quantum storm.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.